Hello everyone. In this video, we will be talking about Pascal's principle. Pascal's principle states that when a pressure in a confined fluid is externally increased, at every point in the fluid, the pressure will go up by the same magnitude. What does this mean? Simply put, it means that the pressure put in externally will equal the pressure outwards at every point in the fluid. So the pressure in will equal the pressure out. From this, we can derive a more useful relation. So we know that force in over area in will equal force out over area out, which gives us a ratio for the force we put in and the force we get out of the fluid will equal the area in which the force is put in or the area the force is exerted. And this is the important conclusion that we derive from Pascal's principle. This is an important relation we use in fluids to apply to machinery. The ratio of the forces will equal the ratio of the areas we put in. So, if the ratio of the area is such that the force that we put into one area and the force coming out in a different area is bigger. This is an important relation because if our area in is a small area such as this, but we increase the area on the other facet of the fluid, we can increase the force exerted at the other facet. Let's look at an example problem where we apply this to machinery. Let's look at this hydraulic press. We have a small sample of 0.5 meters squared set on a stage here, and the hydraulic press has two main chambers, one with the diameter of 15 centimeters and the smaller one with the diameter of 1 centimeter. We can use this lever to push down on the smaller chamber to exert a force. Let's say we exert a force of 200 newtons to press down on the fluid here. What is the pressure exerted on this sample? We will begin this problem by first using Pascal's principle to figure out the amount of force exerted in the bigger chamber. So we know the force put into the system or the force coming out of the system will equal the ratio of the area in over the area out. We have two cylindrical chambers, so we will use the area of a circle. So if we want to know the force out, it will be the product of the force in with the area out over the area in. Expanding on this, we get the force that we put in, which is 200 newtons, times pi, times the radius squared. Since we have a diameter, it will be half of the bigger chamber diameter, which is 0.15 meters squared, over the area of the smaller chamber, which will be 1/2 times 0.01 squared. From this, we will find that the force out of the bigger chamber will be 4,500 newtons. To find the pressure that is exerted on our sample, we will use this force out of 45,000 newtons and our area of 0.5 meters squared. We know that pressure is the force exerted over the area. Our force exerted is 45,000 newtons over an area of 0.5 meters squared. So the overall pressure that is exerted on our sample is 90,000 pascals. This example shows a wonderful application of Pascal's principle to develop machinery to help make our lives easier. Pascal's principle will mainly involve using this relationship to figure out how the force is increased using the ratio of the areas. Thank you for watching and see you for the next video.
I hope you found this video really helpful.
The concepts and information presented in these videos will be true no matter what physics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you're a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website at www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.